We'll continue our Flutter for Beginners series with the web page Write Your First Flutter App on the web. What you'll build. You'll implement a simple web app that displays a sign-in screen. The screen contains 3 text fields: first name, last name, and username. As the user fills out the fields, a progress bar animates along the top of the sign-in area. When all 3 fields are filled in, the progress bar displays in green along the full length of the sign-in area, and the sign up button becomes enabled. Clicking on the sign up button causes a welcome screen to animate in from the bottom of the screen. The animated GIF shows the app works at the completion of this lab. So we have it here. As you fill this in, bar changes color, green in full, and then the sign up button becomes enabled, which then brings up the welcome, which is a separate screen. What you'll learn: how to write a Flutter app that looks natural on the web, basic structure of a Flutter app, how to implement a tween animation, how to implement a stateful widget, how to use the debugger to set breakpoints. The next few sections here describe what's required, what you need. To enable web development, of course, you need to be in a separate release channel, not the stable release channel, but in this case beta. And in fact, you'll have to configure Flutter to enable web development. They just demonstrate here by issuing the flutter doctor command. In this case, this individual is in the release channel dev. There are 4 channels, as you may know: master, dev, beta, and then stable. Further, they then list the devices. Since we've been enabled in web development, we have access now to our Chrome. In particular, they encourage us to use Chrome. The Chrome device automatically starts Chrome. The web server starts a server that hosts the app so that you can load it from any browser. Use the Chrome device during development so that you can use Devtools, and the web server when you want to test on other browsers. So let's quickly do that now and just simply demonstrate those commands. I'm going to type in flutter doctor. And of course, yes, it does bring up beta. And 3 devices are found. Flutter devices, of course, conveys what we want. Chrome, and as it happens, I have Edge as well, but they encourage us today to use Chrome. The starting app is displayed in the following dartpad, so they even allow you to run it in dartpad, but we'll get on with our exercise here and take a copy of this code, minimize it, and paste it in there. I will paste it in there and then I will promptly run it. I already selected Chrome as the desired browser. And there we are. At this point, I suspect it doesn't do too much. No, it just fills in. We have a form here with 3 fields, and right now it's not enabled. So let's continue. Run the example, copy the code, and create a Flutter project. We did that. The entire code for this example lives in the main Dart file. If you know Java, the Dart language should feel very familiar. All the app's UI is created in Dart code. For more information, see Introduction to Declarative UI. The app's UI adheres to Material Design, visual design language that runs on any device or platform. You can customize the Material Design widget, but if you prefer something else, Flutter also offers Cupertino widget library, which implements the current iOS design language. or you can create your own custom widget library. In Flutter, most everything is a widget. Even the app itself is a widget. The app's UI can be described as a widget tree. Step 1. Show the welcome screen. The sign-up form class is a stateful widget. This simply means that the widget stores information that can change, such as user input or data from a feed. Since widgets themselves are immutable, can't be modified once created, the Flutter stores state information in a companion class called the state class. In this lab, all your edits will be made in the private sign-up form state class. Fun fact, the Dart compiler enforces privacy for any identifier prefixed with an underscore. For more information, see Effective Dart Style Guide. First, in our main Dart file, add the following class definition for the WelcomeScreen widget after the sign-up screen class. Alright, I'll copy that. Again, I love Dart in that it's not adhered to any rules, unlike Java. In a Dart file, you can have any number of classes. You can have high-level functions, high-level variables. You're not dictated naming the file itself by the name of the main class. You can name the file anything you want and have anything in there. So let's do this now. After this class, we're going to put in a new class called WelcomeScreen. WelcomeScreen. Okay, here we are. Let's continue. The welcome screen, okay. Next, you'll enable the button to display the screen and create a method to display it. Locate the build method for the sign-up form state class. This is the part of the code that builds the sign-up button. Notice how the button is defined. It's a flat button with a blue background, white text that says sign up, and when pressed does nothing. Update the onPressed property. Change the onPressed property to call the non-existent method that will display the welcome screen. So you change onPressed null to the following. And we'll do that. So we'll go here. There's the null. I'm going to paste that in there. So right off the hop, you can see that the IDE, in this case Android Studio, is complaining. It doesn't know. It's got a red underline. So that function is undefined. Again, this identifier is prefixed with an underscore. Hence, this method, this object, this identifier can only be accessed within this file called main.dart. What is this? Now, we see this is a widget called flat button. It has a number of named parameters. I'm going to look at this one. So now we're in this class. It extends the material button. What is this quickly? A material designed flat button. A flat button is a text label displayed on a zero elevation widget that reacts to touch by filling with color. Okay, so we go down here. We notice that it's a constant constructor, hence we know that there's nothing mutable inside this class. Nothing changes. Everything, its properties, its instant variables are all final, if any. So here, the name parameter is required. So you need to pass this value, this parameter, this argument, and this argument. This one's required widget, and it's child. It's called child. It, in fact, is the white text, the word sign up. Phrase sign up. So, what is this void? Everything is a type in Dart. This type is defined as a function. You can pass functions as parameters, of course. So this function returns nothing. Right now, it's complaining about this. we'll go on now and see, add the show welcome screen method. Fix the error reported by the analyzer, that's that red underline. That show welcome screen is not defined. Directly above the build method, add the following function. Okay, we'll do that. Click on this. Above this build screen, let me just quickly demonstrate now. Before I do that, see, there's no complaint there. This is suddenly a high-level function within this Dart file, and it's perfectly legal. It now has defined it. It knows where it is. Unfortunately, the const thereof is complaining because this is actually a getter, a property of the class state. So we got to bring that back into that state, into that class, above build. Excellent. Look at that. Again, no complaints. Now again, I would suggest, since this is already library private, why do we need to have this with the underscore? That's my understanding, is that it's within a class, within an object that's private anyway. All these could be without their underscores, can they not? You tell me. Go like this. I'm just going to be the rebel that I am. Change that for now. I'll correct it otherwise. Okay, so this should work now. I'm going to save this. Hot reload. Sure enough, look at that. Blue now. See the color flat, blue and white. If I click on it, what happens? Nothing. Okay. Yeah, of course I'm getting ahead of myself, aren't I? We have to invoke that now. We actually have to go to that screen. This screen here, this class. Ah, I see where I've gotten ahead of myself. It's actually asking for the root. In Flutter, screens and pages are labeled or considered roots. In this case, the navigator object, the navigator class, is looking for a particular root called welcome. Well, that has yet to be defined within this application, and that's defined in the material app. Go on, let's press on here. Observations. The show welcome screen function is used in the build method as a callback function. Callback functions are often used in Dart code, and in this case, this means call this method when the button is pressed. Flutter has only one navigator object. This widget manages Flutter screens, also called roots or pages, inside a stack. The screen at the top of the stack is the view that is currently displayed. Pushing a new screen to that stack switches the display to that screen, to that new screen. This is why show welcome function pushes the welcome screen onto the navigator stack. The user clicks the button and voila, the welcome screen appears. Otherwise, calling pop on the navigator returns to the previous screen because the Flutter navigation is integrated into the browser's navigation. This happens implicitly when clicking the browser's back arrow button. Okay, so I missed a spot here. Oh, okay, this step 4. Add the welcome root. Create the connection to show the new screen. In the build method for sign up app, add the following root below the home root. That reminds me back of the DOS days. The root of the directory. So let's copy that. Right? Go back to the app sign up app class. Of course, it contains. It's a stateless widget, but it contains, it's the basis, it's the widget actually passed to run app, the run app function. Click on that, and it's expecting a widget. This is a widget. It contains, its build contains the material app, and we'll place this in its routes. So, what is that? It's a map. It's a map with its keys here as strings. And then this object here, this object is a widget builder, I would suspect. Let's see, go back here. Widget builder. What's that? The app's top-level routing table. When a named route is pushed with the navigator push named, the route name is looked up in this map. If the name is present, the associated widget builder is used to construct a material page route that performs an appropriate transition, including hero animations, to the new route. Notice when I clicked on it earlier that there was no complaint. It just simply doesn't do anything. It just stays right in the original screen. So let's see. Now everything's a type. Let's see what type this is. Signature for a function that creates a widget. So it's a function. It takes in the build context object and returns a widget. Excellent. So this hero animation, now that's what we saw when the welcome screen comes up. It comes up from the bottom. It flies into the screen. So that's hence what they call the hero animation. Go back now. We've got that in there. Save. Now that I hit it, ta-da, brings it up. I hit the back arrow. If I hit the back arrow, what happens? Nothing's happening. Front, back. All right. I don't like that. What'd I miss? Well, let's go on. Let's continue on here. The sign up button should now be enabled. Click on it to bring up the welcome screen. Note how it animates in from the bottom. You get that behavior for free. Oh, thank you. Observations. The show welcome screen function is used in the build method as a callback function. Callback functions are often used in Dart code, and in this case, this means call the method. I read all this, didn't I? Let's go back here. Enable sign-in progress tracking. This sign-in screen has 3 fields. Next, you will enable the ability to track the user's progress in filling in the form fields, and update the app's UI when the form is complete. This example does not validate the accuracy of the input field. This is something you can add later. Guess what? We'll add later. Add a method to update form progress. In the sign up form state class, add a new method called update form progress. All right. So let's do that. Let's go back here. In this state, add a new method. Perfect. It's complaining now because I took off the... Now it's seen as a property of that class. Okay. Call the update form progress when the form changes. Okay, so that's going to call in the form on change argument. All right. In the build method of the sign up form state class, call a callback in the form widget's on changed argument. Add the code below marked as new. Alrighty then. Let's do that. Here's the form widget. Right then and there between the child, we'll do this. And it will call that. Again, I'm in a private. Why the heck do I need to do that? That should be just as fine. You tell me if I'm wrong. Okay. Did that. Update the onPressed property again. In step 1, you modify the onPressed property for the sign-in button to display the welcome screen. Now update the button to display the welcome screen only when the form is completely filled in. Okay. So we're taking this line. I like that. Notice how you can put comments at the end. So that makes sense. Look, so let's go here. Change this. to that. Introduce this again. Introduce this again. It's okay to return null when this instant variable, this property of this class equals 1, return, supply this to the onPressed argument, otherwise pass null. Okay, so when things change, and things often do, this will be called. Okay, try not to get ahead of myself here. The sign up button is initially disabled, but becomes enabled when all three text fields contains any text. Okay, let's look at the observations first. Calling a widget's setState method tells Flutter that the widget needs to be updated on screen. The framework then disposes of the previous immutable widget and its children, creates a new one with its accompanying child widget tree, and renders it to the screen. For this work seamlessly, Flutter needs to be fast. For this to work seamlessly, Flutter needs to be fast. The new widget tree must be created and rendered to a class screen in less than 1/60th of a second to create a smooth visual transition, especially for animation. Luckily, Flutter is fast. The progress field is defined as a floating value and is updated in the update from progress method. When all three fields are filled in, form progress is set to 1.0. When form progress is set to 1.0, the onPressed callback is set to show WelcomeScreen method. The button is enabled when the onPressed argument is non-null. Notice that the update form progress passes a function to setState. This is called an anonymous function and has the following syntax, where method name is the named function that takes on an anonymous callback function as an argument. The Dart syntax in the last step that displays the welcome screen is this. Yes. It is a Dart conditional assignment and has the syntax condition $!expression1 : expression2. If the expression, in this case form progress equals 1, is true, the entire expression results in the value of the left-hand side of the colon, which is the show welcome method in this case. Okay. Alright, see. That's interesting. So, as you may know, you initiate a setState. It's going to call the stateObjects build function soon after. This method takes in an anonymous void callback function. What's a void callback function? Remember? It's a function that returns nothing. You may have gone through this before. It calls that function literally right there in that fashion. Returns any particular type. It's not expecting any type, so we use dynamic. It checks during development whether it's a future. It's not good to associate an asynchronous process with a synchronous process, so returning a future is a no-no. Let's go back here to main. So that calls there. We didn't run this yet. Let's run this, right? Okay. I'm going to restart it. Why? Because I can. The main Dart, okay. It always starts in debug mode. Because I clicked on the debug button in this case. I could have started using Flutter run device Chrome at the command line terminal window. Let's do this. So I type in something, type in something, type in something. Look at that. The moment I type it, this is enabled. Hit sign up. Ta-da! Welcome comes on. If I hit the back button, there we go. That's right. It should come back. So it came off the stack. ABC. The navigator takes in the root. Welcome. There. It calls this class. Let's go to this class. I hit that. I'm going to put a breakpoint there. Why? Because I like getting ahead of myself. So if I do it like that, go back here, hit sign up. Look at that. What did it do? That's interesting. We inflate the new child. We mount the new child. Yes. Update child. Inflate the widget. Okay, I'm really getting ahead of myself, aren't I? And first build. Perform build. And there's the build right there. That's the R build function. And that build function, ironically, calls the widget's build function. In this case, a stateless widget. Scaffold. Okay, I'm always going to get ahead of myself, by the way. What I do. Here we go. So let's do this. Launch the Dart Devtools. How do you debug the Flutter web app? It's not too different from debugging any Flutter app. We want to use Dart Devtools, not to be confused with Chrome Devtools. Our app currently has no bugs, but let's check it out anyway. The following instructions for launching Devtools applies to any workflow, but there's a shortcut if you're using IntelliJ. Okay, we can look at that later. Run the app. You're currently not running it. Let's do that. Let's close this. If your app isn't currently running, launch it. Select the Chrome device from the pull-down menu and launch it from your IDE or from the command line using this. So let's go to the command line. Put that out of the way. There. You can't really see that, can you? There you go. What? Flutter run deep. This command should run from the root of your Flutter project. Oh. Oh. How come I'm not in that Flutter project? Okay, there we go. Now I'll type in the command. Flutter run Chrome. 2 runs it in debug mode. Okay. Enabled. Hit. Excellent. Hit the back button. Perfect. Okay, go to the WebSocket for... Okay, let's do this. Get to the WebSocket info for Devtools. At the command line or on the IDE, you should see a message stating something like the following. Okay, debug. Okay, right. Copy the address of the debug server, shown in bold. You will need that to launch Devtools. Ensure the Devtools installed. I have that installed. Connect. When Devtools launches, you should see something like the following. Well, I've already got it installed, so I can just do this. Can I not? So I'm in here. I don't have to access this. I got it right there. Open Devtools. I click on that now because it is a plugin for Chrome. It's going to actually start up in a Chrome browser window. Here we go. And there we are. Detailing the widget tree with that sample app. Now, if I go to debugger, there's the main Dart file right there. So we're actually in the same browse window. Okay, so using the connect to a running app. Under connect to a running app site, paste your... I'm not doing all that. To heck with that. See, this is what I did. I simply clicked on that button. Set a breakpoint. Now that you have Devtools running, select the Debugger tab, the blue bar along the top. The debugger pane appears, and in the lower left, see a list of libraries used in the example. Select Sign Up Main Dart to display your Dart code in the center pane. No. Set a breakpoint. In the Dart code, scroll down to where progress is updated. Okay. Place a breakcode on the line with the form loop by clicking on the left of the line number. The breakpoint now appears in the breakpoints section to the left of the window. Trigger the breakpoint. In the running app, click one of the text fields to gain focus. The app hits the breakpoint and pauses. In the Devtools screen, you can see on the left the value of progress, which is 0. This is to be expected since none of the fields are filled in. Step through the for loop to see the program execution. Resume the app. Resume the app by clicking the green Resume button on the Devtools window. Delete the breakpoint. Delete the breakpoint by clicking it again and resume the app. This gives you a tiny glimpse of what's possible using Devtools, but there's lots more. For more information, see the Devtools documentation. That will be another video. So we got to go through here. There's the Devtools documentation. We'll look at that another time. We'll have to look through this another time too. I'm getting bored. Alright, I'm bored. So let's go here, because I like the fact that the Devtools actually respects the associated IDE. You can just simply click. For example, they ask us to click here within the update form progress method. I'm going to click there. And if we go now back to Devtools, it shows up there. Perfect. If I click off, it's gone. Love it. So let's demonstrate this. We're in here. If I click on something, it stops. The moment I make a change in the form field, the controllers take over. Controllers are assigned to each form field. They actually contain the values and dictate what happens. So there's one for the first name, last name, and username. Here's the controllers here. Okay. First name, last name, username. Value blank, this one should be A. There's a little A right there. Perfect. So what happened? How did I get here? Well, we clicked on, we assigned a new value, a text editing value, to the widget controller value. So we set it to this widget called form. This widget here called text form field. Here it is. That widget has a controller and it's assigned a value. Like that. Boom. When you set that value, you notify listeners. So it's going through all the listeners, and that's what we just assigned. We just assigned a listener back here. One of those listeners is right here. Update form progress. So let's see that now. Let's see how that works. So super did change value. Form, this of method, this is a static function. As you can see, goes through the widget tree and finds the first form state. Right? It then calls that form state's field did change method. So let's quickly go back to our form. What is our form? It is a stateful widget. See that? Hence, it has a companion class called, well, guess. It's called a form state. It seems to be the convention here. The name of the state object is always the name of its companion class, with the word state appended on the end. There is that method. It called form field did change. So if the widget itself is not null, checks that, see if it's not null, it's going to call it, and there it is. It's not null, it's up here. On change. Easy peasy, huh? So now it's going to go through its controllers. Oh, we've actually dictated. Here, I think there's an easier way to do this. You can actually get that from the form itself, can't you? The list. Here we've generated a list. That could have been easily called this, couldn't it? In fact, it'd be called, you can declare it a list of type that would be just the same, and that is a double. Again, they use vars. I don't like using vars. I personally think it's kind of lazy, but hey, that's me. We're going to do this, and it's going to scroll through this stuff. If the text is not empty, it is empty in two of them, so it will go past two of them. Not the first one. It goes past the second one, and it goes past the third one. So what's progress? Is it 1? 1.0? No. It's still not 1.0. In other words, that form, that double instant variable, still not 1.0. I can change that to 1.0 and that would work. Hence, this will still return null. Nope. B. Now, I'm going to go back. Go back to the form. Click here. Put the breakpoint there. I'm going to hit C. It stops. Progress is now 1. Since that's 1, and we're in a set state method, guess what's going to happen? This build will soon fire. Soon after that is executed. The set state is called, then comes the build function. It'll be called. And that will equal 1. Hit the green button to continue. Sure enough, we're now in the build method. Click again. Oh. Of course. I got to hit sign up, right? I got to hit that button now. So when I do, ta-da! Oh, it doesn't breakpoint there. Come. Can I put a breakpoint here? Let's watch that now. And I go back. Boom. Okay, I hate that. And look at that, it doesn't correspond. It's a one-way. Turn that off. Go like this. Go like that. Go back to it. And there it is. I love that. Doesn't go the other way. I prefer using the IDE. If I go in here, go like that. Go to long press. Oh yeah, we're in there. Now we're in the parent. Right? Right. The parent is a stateful widget. You know me, I'm going on a tangent again. It's enabled. Oh, look at that. Get enabled. It's not null. And it's not null. Raw material button. Look at that. Going way back deep into the... Okay, where's this going? It's going deep. InkWell. Oh, look at that. So yeah, it's a flat button. All right. OnTap. It's just a gesture. Tap callback. Oh my goodness, going all the way. How far does this thing go? Okay, how do I run it? Stateful widget. Okay, I've gotten way ahead of myself, haven't I? Handle tap. Okay. Boom. Wow. We're way down there. Look at that. It finally hits it. Goes back into the tap. First it gets the getter. Gets the widget. We find the widget. We hit OnTap. What does OnTap do? Navigator to context. So it finds the first state. Look at that. That's it. We're in it. But as you can tell, we got a lot to learn about that Flutter framework. So now we're in. Okay. Add animation for sign in progress. It's time to add animation. In this final step, we'll create the animation for the linear progress indicator at the top of the sign-in area. The animation has the following behavior. When the app starts, a tiny red bar appears across the top of the sign-in area. When one text field contains text, the red bar turns orange and animates 0.15 of the way across the area. When two text fields contain text, the orange bar turns yellow and animates half of the way across the sign-in area. When all three fields contain text, the orange bar turns green and animates all the way across the sign-in area. Also, the sign-in button becomes enabled. Add the animated progress indicator. At the bottom of the file, add this widget. In other words, add this class. And we'll do that now. So we'll go to the bottom. Add another class. I love that. Dark lets you do as many classes as you want. Okay. It's library private. Can't be accessed elsewhere. This is the companion class. It's another widget. Use the new animated process indicator. Then replace the linear progress indicator in the form with this new. Okay, let's do that. Animated progress indicator. Copy that. Okay. Let's go back to the form. Here's the form. In its children, for this column widget, it had this linear progress indicator. So we go back. That's this thing here. As you can see, that little line right there. So we're going to get rid of it, apparently. Place it with this one. So let's do that. Right? Again, I did some changes of my own. That should work. The widget uses an animated builder to animate the progress indicator to the latest value. Run the app. Type anything in the 3 fields to verify the animation works. Then clicking the sign up button to bring up the welcome screen. Okay. Let's do that. Save. Oh, yes, rebuilds. Beautiful. So now, it's red. A. Okay. B. I said B. Halfway. Yellow. And this should turn green. All the way across. This is now enabled. I hit that. Of course, we're deep in the framework. It's running this handle. And it does. Excellent. That is wonderful. Go back to the main. I got all these windows open here. Let's go back. I'm going to put them both on there. Why not? I want to see what happens. What's going on here? They're both there. Turn that off now. And there's the completed one in the dart pad. Observations. You can use AnimationController to run any animation. The animated builder returns the build tree when the value of the animated animation changes. Use a tween. You can interpolate. You can insert between almost any value, in this case color. Congratulations, you've created your first web app using Flutter. So let's do this now. What's this animation builder? Let's go back here quickly and see what we did. This is the InkWell. We got to get out of there. Okay, so animated progress indicators and our new stateful widget, our new class. It requires this. Okay, so we provide a value. Then we call, creates the state. This is one line, by the way. So we could use the narrow notation here. Get away with that. It says, this is not really necessary either. You can just simply do this. It's true, don't get me wrong. But it returns a state object, and that's what the framework wants. Simply a state object. This state object, though, is associated with this widget, which is that widget. So any reference to the word widget to its getter will provide us with that stateful widget. Here's that animation controller it speaks of. So animation controller. There's the controller. It updates to animate to a new value. I'm going to put a breakpoint there. So the animation builder requires that controller. And there's the builder. And there's that linear progress indicator again. This time it's given a specific value, a curve, its progression, its color, and its background. Oh, what happened? How come I can't? There we go. Okay. Let's do this. A. Now we're in the builder. Right? Then let's go to the debugger. We're updating that child. Perform build. Update children. Update. So it calls that state objects did update widget. So there's the new value. There's the widget. What widget is that? That we know is the animated progress indicator, which is up here. This class right here. And there it has a state value. I'm sorry, an init. This is immutable. Hence, this is final. So this is being recreated over and over and over again every time we build. But this state object stays consistent and is retained in memory. We build controller. It won't let me put a breakpoint there. Every time we change something, the widget value is changed. Hence, that widget is being rebuilt. Hence, this build is being recalled. Excellent. Well, I'll leave it at that. I'm sure we'll have a lot of questions. We'll be working with this throughout our live session, no doubt. Great stuff.